All right, let's look at the solutions for our sample test. For number one, we have the arc sine of 1/2. All right, remember that arc sine literally means inverse sine. So that means that sine theta equals 1/2. We're playing Jeopardy. They're giving us the answer and they're looking for the question. And we only have first and fourth quadrants to choose from. We get all that from the definition of arc sine. And so because it's positive, we know we're in the first quadrant. If it had been a negative 1/2, we would have been in the fourth quadrant. So we're going to look on our unit circle in the first quadrant and see where the y value is 1/2, and that's at pi/6. All right, then arc cosine of negative square root of 2/2. That means that cosine is equal to negative square root of 2/2, and we only have first and second quadrants to choose from. We get all that from the definition of inverse cosine. So because it's negative, we know that our answer is going to have to be in the second quadrant. If it had been positive, we would have known it was in the first quadrant. So we're going to look on our unit circle in the second quadrant and see where the x value is negative square root of 2/2, and that is at 3 pi/4. All right, then inverse tangent of negative square root of 3. Now, for your tangent values, remember that you're going to do sine divided by cosine, or y divided by x. So you don't have those values on your unit circle, but you can add them on in that way. So if we have the inverse tangent of a negative square root of 3, we know that means that tangent is equal to negative square root of 3, and we only have first and fourth quadrants to choose from. Inverse sine and inverse tangent are first and fourth. Inverse cosine is first and second. So tangent is negative in the fourth quadrant and positive in the first. So we're going to look in the fourth quadrant and see where tangent equals negative square root of 3. And that would be at a negative pi/3. Now you could also write that as 5 pi/3, and it would be fine. In WebAssign, you're going to have to write it as negative pi/3. All right, look at the next one. So for the next one, we have the arc sine of the sine of 11 pi/6. Now, because these are inverses, you can cancel them whenever this value is within the designated region. What do we mean by that? Again, arc sine is 1 and 4, and arc tan is 1 and 4. Arc cosine is 1 and 2. So because 11 pi/6 is in the fourth quadrant, and that is in the designated region for inverse sine, then we can just cancel, and our answer is 11 pi/6 or negative pi/6. You can write it either way, but again, in WebAssign, they're going to want it as negative pi/6. All right, number 5, we have the arc sine of the sine of 7 pi/6. Now, we can't cancel here. The only time you can cancel is when this value is in the designated region, right? And so for arc sine, the designated region is 1 and 4. 7 pi/6 is in the third quadrant. So we can't cancel. We'll start with just what is the sine of 7 pi/6. So look on your unit circle, and the sine of 7 pi/6 is negative 1/2. And now we're back to the same kind of problems we had in numbers 1, 2, and 3. We're saying that inverse sine of negative 1/2, that sine is equal to negative 1/2, and we only have first and fourth quadrants to choose from. Since this is negative, we're in the fourth quadrant. If it had been positive, we'd be in the first. And so we're going to look in the fourth quadrant for where sine is equal to negative 1/2, and that would be negative pi/6 or 11 pi/6. But again, WebAssign will want you to write it as negative pi/6. All right, look at the next one. So for the next one, we have, again, another composition. We've got the cosine of the inverse sine of negative 3/5. Now, negative 3/5 is not a value on the unit circle, and so we'll have to build a triangle for it. So two things that I need to get from this inside piece of information. I need to get the triangle values, and I need to get the quadrant that I'm in. So if I have inverse sine of negative 3/5, that means sine equals negative 3/5, and I only have first and fourth quadrants to choose from. Because it was a negative 3/5, I have to be in the fourth quadrant. If it had been a positive 3/5, I would have been in the first quadrant. So in my fourth quadrant, if sine is negative 3/5, sine is opposite over hypotenuse. Remember that the hypotenuse, or the radius, always has to be positive, and in the fourth quadrant, y would be negative. So then I can do Pythagorean theorem to get my other side, or recognize the 3, 4, 5 triangle, either one. And so we've got our quadrant, we've got our triangle values, and so now we can find what the cosine of that is, because that was the question that was asked. So looking at the triangle, we can say cosine is adjacent over hypotenuse, so that would be a positive 4/5. All right, for number 7, we're graphing, and they ask us to graph y is equal to 3 sine 1/2 x. So remember that when you have a number out in front of the function, that's going to change the amplitude. That's a vertical stretch by a factor of 3. And when you have a number in between sine and x, that's going to change your period. So this is your b value, 1/2. So your period, your new period, is going to be the original period divided by b. And the original period for sine is 2 pi. So if we do 2 pi divided by 1/2, we're going to get 4 pi as our new period. So our normal sine curve goes up to 1 and down to -1. So you could draw your normal sine curve on here first, where you're going up to 1 and then you're going down to -1. Then we could go back through and we could change the amplitude so that it goes up to 3 and then it goes down to -3. And then the only other thing that we would need to do is change its period. So remember, that means that I'm not done drawing it until I get to 4 pi. So if I'm going to draw this so that I don't finish until I get to 4 pi, then I'm going to start at 0 and stop at 4 pi. Halfway in between is where my other x-intercept is. So half of the graph is between 0 and 2 pi, and half of the graph is between 2 pi and 4 pi. Because again, remember, b tells you how much of the graph you're going to put in the same amount of space you normally put 1. So we're going to put half in the same amount of space that we normally put 1. So if you want to, you can change the scale on your graph if it's pre-drawn for you, or you could extend it out further if you were drawing it yourself. All right, look at number 8. So for number 8, we've got y is equal to 1/2 cosine 2x. So first off, our cosine curve normally starts at 1 and goes down to -1 and then comes back up to 1. And normally when we draw it, it takes from 0 to 2 pi to draw one cycle of it. The 1/2 out in front is going to make it go half as high and half as low. And then the 2 in between cosine and x is going to change our period. So our new period will be 2 pi divided by b. So 2 pi divided by pi would be 1 pi for our new period. So again, I want to draw this, instead of it starting at 1 and going down to -1, I want to draw this so it starts at 1/2 and goes down to -1/2. I also need to draw it so that I am done by the time I get to 1 pi, so that I've completed the whole cosine curve by the time I get to 1 pi. So what I can do is give myself a couple of key points, because I know that it normally starts at the maximum and ends at the maximum, and halfway in between is the minimum. Then I can just give myself the starting point at the maximum, the end point at pi at the maximum, and then halfway in between that at pi over 2 would be the minimum. Or we can also think of b as 2. That's what we're going to put in the same amount of space that we normally put 1. And so you can see there's 1 complete curve, 2 complete curves in the same amount of space that we normally put 1. All right, look at the next one. So for the next one, we have y is equal to negative sine x plus pi minus 1. So our normal sine curve, you can see dotted right here. So there's our normal sine curve. So we have a couple things going on the pi is going to cause a horizontal shift because any value subtracted from x is a horizontal shift. So that'll be a horizontal shift of negative pi because it's x minus a negative pi. Then any value subtracted from y, if you'll notice, this could be moved to the other side and subtracted from y. So any value subtracted from y is going to be a vertical shift. So that is a vertical shift of -1. And then the negative out in front of the entire function causes a reflection in the x-axis. Remember that for the order, we want to reflect before we vertically shift. So let's horizontally shift first. So again, dotted is our normal sine curve. So we have a horizontal shift of negative pi. So I'm going to take that and I'm going to back up pi, and then I'm going to draw the exact same thing. So you can see I have that labeled. That was the horizontal shift of negative pi. Then I want to reflect. So let's take that graph we just drew right there and let's reflect it in the x-axis. So the darkened one is my reflected graph in the x-axis. And then last I have a vertical shift of a -1. So I'm going to take that darkened graph we just had a second ago and I'm going to move it down 1. So just pick some key points and drop each one of them down 1, and then you can connect that and in some way tell me, hey, this is my final answer. That's the one that I want you to check. Now we've talked about amplitude and period on 7, 8, and 9, but we've not talked about midline. Your midline is going to be the same as your vertical shift. So if you'll notice on this one, because we had a vertical shift of -1, our midline was y equals -1. But on these other two, there was no vertical shift, and so you'll notice both on 7 and on 8 that our midline was just y equals 0. Okay, so then we get to number 10, and for number 10 we are working on our simplifies. So the steps that we had for that, step number 1, we want to look for any Pythagorean identities, and that's a trig function squared, especially if it's paired with a 1 or another trig function squared. So when we start, we've got a secant squared minus 1. That almost has to be a Pythagorean. So if you look at your Pythagorean identities, yes, that's equal to tangent squared. Also, we have 1 minus sine squared. That's also equal to a Pythagorean. That's cosine squared. All right, so go back to the top of your list again. Step number 1, do you have any trig function squared? Yes, but I don't want to undo what I just did. Step number 2, do you have any fractions that you could combine or break apart? No. Step number 3, could you factor? Well, the trick we used for factoring was to replace the trig function with a variable. So this would be like a squared times b squared. A squared, b squared can't be factored. So when all else fails, we're going to change everything to terms of sine and cosine. So tangent, remember, is sine over cosine. So that would be sine squared over cosine squared. And then we just still have cosine squared over 1. So you'll notice that the cosine squareds would cancel, and that would leave me with sine squared. So that would be my simplified answer. If instead that had been a verify, they would have told me from the beginning to verify that it was equal to sine squared. All right, here's another one. Cotangent negative x over tangent pi over 2 minus x. This is literally just using some of our identities. So this is an even-odd identity. So if you look at your even-odd identities, cotangent negative x is negative cotangent x. And this is a cofunction identity. Tangent of pi over 2 minus x is cotangent x. All right, so go back to the top of your list. Do you have any trig functions squared? No. Step number 2, do you have any fractions you could combine or break apart? No. Step number 3, could we factor? Well, if we put a variable in here, this would be like negative a over a. Well, if you have a over a, that'll cancel and just be 1, right? So negative cotangent over cotangent would be -1, and that would be its simplified form. All right, for number 12, we are verifying. So for number 12, we know what we're trying to get to over here. We're only allowed to work on one side of the identity. So cotangent is cotangent plus tangent. Step number 1, I don't have any trig functions squared. I don't have any fractions. That would be like a plus b, so there'd be no way to factor that. So I'm going to change everything to terms of sine and cosine. So cotangent is cosine over sine, and tangent is sine over cosine. So now we go back to the top of our list. I don't have any trig functions squared, but now I do have fractions that I could combine. So the common denominator for sine and cosine would be sine cosine. So to go from here to here, I had to multiply my denominator by cosine. What we do to the bottom, we have to do to the top. So we're going to have multiplying by cosine in the top as well. All right, then how did I get from here to here? I had to multiply by sine in the denominator, and so I'm going to have to do the same thing in the numerator. So I'll have sine times sine in the numerator. So to simplify that, now I have cosine times cosine, which is cosine squared, and sine times sine, which is sine squared. And the purpose of getting the common denominator was so that we could combine over that common denominator. Alright, so we go back up to the top of our list, and step number 1, do we have any trig functions squared? Yes, we have 2 trig functions squared, so that almost has to be an identity. And sure enough, if you look at your Pythagorean identities, that is equal to 1. And so now we have 1 over sine times cosine. So 1 over sine is cosecant, and 1 over cosine is secant. Now, just a reminder that if you got to this step and you were kind of stuck and you weren't sure what to do, remember that you can always take your answer and put it down at the bottom and then work your way up from the bottom to the top. All right, then for number 13, they ask us to factor. So if it makes it easier for you to see, remember that you can substitute this out. So that would be like 2x squared minus 4x plus 2. So if you factor 2x squared minus 4x plus 2, you would get 2x minus 2 and x minus 1. So all we have to do then is just put our sign in the place of x. So 2 sine x minus 2 times sine x minus 1. Also remember that you have the SAT/ACT program on your calculator that has a quadratic component that factors for you if you need assistance with factoring. Alright, for number 14, they want us to go ahead and take that a step further and solve that last problem that we were just working with. Alright, so here were the factors that we just had a second ago. So of course once you factor something, you're going to set each of those factors equal to 0. So let's start with this piece. We're going to add 2 to both sides and then divide both sides by 2. So we would have sine is equal to 1. So on your unit circle, where is your sine equal to a positive 1? Well, that's at pi over 2. And then over here, if we add 1 to both sides, we'll get sine equals 1. So again, sine is equal to 1 at pi over 2. Alright, then for number 15, one more of these that we're solving. So I want to try and get the trig function alone on one side by itself. So if this was 4x squared minus 1, what would you do? Well, you would add 1 to both sides. So let's add 1. And then we would divide both sides by 4. So we'll have cosine squared is equal to 1/4. Now, I need to get rid of that square. And to get rid of a square, we insert a square root. So we'll insert a square root on both sides, and when we do, remember that we put in a plus or minus when you insert a radical. So square root of cosine squared is cosine, and the square root of 1 is 1, square root of 4 is 2, so we would have plus or minus 1/2. So cosine is equal to a positive 1/2 in the first and fourth quadrants. Is equal to a negative 1/2 in the second and third quadrants. So we're actually going to give an answer in all 4 of the quadrants. So if you look on your unit circle and you see where your x value is 1/2 or negative 1/2, it's at pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3.